Wherever you are right now, I hope you're comfortable. Maybe you're lying down, lights dimmed, the quiet hum of the world fading softly into the background. Tonight, under the slow rhythm of thought and breath, we'll drift together into a question so vast, so quietly profound, that it feels like standing at the edge of the universe itself. Did nothing ever exist? The word nothing seems simple: an absence, an empty cup, a silent pause between notes. But the deeper you look, the more slippery it becomes. Physicists, philosophers, and poets have all wrestled with it. They've stared into the blank canvas of existence and asked whether true emptiness ever was, or whether even in the deepest silence, something has always been humming quietly beneath. Imagine for a moment the universe before it began. Not darkness, because darkness is still something. It's a field of photons, not yet touching your eyes. Not space, because space itself must first exist to be empty. Not time, because time only ticks when something can change. Strip all that away, and you reach a kind of conceptual cliff. What lies beyond it? Is it nothing? Or is it a realm that words, by their nature, cannot describe? In physics, nothing has never truly meant the absolute void of imagination. Even the vacuum of space, that black expanse between galaxies, is alive with restless motion. Quantum field theory tells us that the vacuum seethes with activity. Particles and antiparticles flickering in and out of existence like faint sparks on the surface of an invisible sea. These are the so-called virtual particles, manifestations of quantum uncertainty that arise from the fundamental fuzziness of the universe's smallest scales. They borrow energy from the fabric of reality itself, appearing and vanishing faster than any clock could measure. This quantum foam, as it's sometimes called, suggests that nothingness, at least in the physical sense, is never truly empty. Even in the coldest, darkest void, there remains a subtle hum, fields trembling with potential, the faint signature of something rather than nothing. It's a reminder that emptiness, too, can hold structure, just hidden from our eyes. But before physics claimed the void, philosophers pondered it for millennia. Ancient Greek thinkers like Parmenides argued that nothing could not exist, because to think of it is to make it something. To him, the idea of true nothingness was a contradiction in terms. His student Zeno followed that logic into paradoxes that still echo in classrooms today. Aristotle, on the other hand, insisted that a vacuum was impossible, that nature abhorred it, and would rush to fill any empty space with matter or air. For nearly 2,000 years, this belief shaped our understanding of reality. Emptiness was an illusion. It wasn't until the 17th century that scientists like Torricelli and Pascal began to challenge that notion. Through experiments with barometers and sealed tubes, they discovered that vacuums could in fact exist, at least in a limited sense. Yet even those vacuums weren't truly nothing. They contained space, potential, the stage upon which something might yet appear. Every advance in science only seemed to push the boundary of nothing further away, like chasing the horizon.
Modern cosmology deepens the puzzle. According to the most widely accepted theory, our universe began about 13.8 billion years ago in a hot, dense state, a cosmic singularity. But the word beginning carries assumptions. Did time itself begin there, or did something precede it? And if time and space were born together, what does it even mean to ask what came before? Stephen Hawking once suggested that asking what happened before the Big Bang is like asking what lies north of the North Pole. The question itself might not make sense, because time, as we know it, could have emerged with the universe. In that case, nothing was never an empty waiting room for creation. It was not a place at all. The universe didn't arise in time. Time arose with it. And yet, even this description leaves us with a haunting feeling. If there was no time, no space, no laws, then what caused the first spark of existence? Was it spontaneous? Was it inevitable? Or is causation itself meaningless in the absence of before? At the frontier of physics, theories like quantum cosmology and string theory have attempted to model how universes could arise naturally from fluctuations in a pre-existing quantum field, or even from the spontaneous instability of nothing. In 2012, physicist Lawrence Krauss argued in his book, A Universe from Nothing, that quantum mechanics allows something to emerge from nothingness because the laws of physics themselves might permit spontaneous creation. But others counter that this nothing isn't truly nothing. It's a field, a set of rules, a mathematical potential, a kind of cosmic blueprint that already contains the possibility of everything. It's almost poetic, isn't it? Even in our attempts to define nothing, we keep finding structure, whispering just beneath the silence. Perhaps nothing is the mirror through which we glimpse how deeply existence runs, how the potential to be cannot fully be erased. So did nothing ever exist? The honest answer is that no one knows. Maybe it never could. Maybe the universe is like an eternal heartbeat, expanding, contracting, recycling energy and matter across endless ages. Or maybe it all began in a trembling instant, a fluctuation in the fabric of reality that bloomed into everything we now see and know. But tonight, we're not here to solve it. We're here to feel the weight of that question, to rest for a while in the wonder of not knowing, the kind of wonder that hums quietly in the background of existence itself. In the next part of our journey, we'll explore the strange dance between something and nothing in greater depth, how the laws of physics, symmetry, and vacuum energy weave together to keep the universe from slipping back into stillness. For now, breathe deeply and imagine that endless, peaceful void, the one that might not exist, yet somehow gave rise to everything.